Hello everyone, hope you all are doing well. So this is the first video of the Leetcode crash course that we are doing. Again, I'm starting with a random problem. So this is a problem related to linked list. The problem name is delete the middle node of a linked list. It's an easy problem. I would say a more traditional problem, but in the beginning of this course, probably we'll be solving some of the easy problem, and then we'll move to the harder problems, right? So yeah, this problem is pretty straightforward. So you are given the head of a linked list, delete the middle node, and return the head of the modified linked list. So the middle node of a linked list of size n is the n by 2th node from the start, using zero based indexing, where this you can see that the floor of x denotes the largest integer less than or equal to the value x. Now these are some of the examples, so let's directly jump into the explanation and see how to approach this type of problem. Again, I'll not be using some jargons as to what is this algorithm and all. Let's see if the first time, if for the first time you are seeing this problem, however you are familiar with linked list concepts, that there are nodes, there is a next pointer or something like that, then how do we approach this problem, right? So we have a linked list here. So so suppose this is value 1, this is value 3, this is value 4, this is value 7. I'm taking the first example only, 1, 2 and 6, right? So how many nodes are there? 1, 2, 3, 4, 5, 6, 7. So 7 nodes are there. Divide it by 2, right? What this problem is saying, so total we have 7 nodes divided by 2, you get 3, right? So delete the third node, remember, or delete the node at index 3, and the indexing is starting from 3, so it is 0, 1, 2, 3, 4, 5, 6. So delete this node, so the new list will become, or I can say 4 will directly point to 1, right? So your new list will be 1, 3, 4, 1, 2 and 6, right? This is what the problem is saying you to do, right? If I take another example, however, I think this must have been understood, but again, let's take an example. So you have this linked list, the number of nodes is 2, divided by 2 you get 1. So this is index 0, this is index 1, delete this node, so the new list will become 2, right? However, there is also an edge case which is not mentioned in any of the examples. Suppose you have only a single node, this is the head node, right? Then what will happen? So obviously the number of nodes are 1, divided by 2 it becomes 0, right? Because you are taking the floor of this value. So delete the 0th node, so you delete this node and you return null. So this is what the problem is saying, right? Now suppose I have a list, right? Let's start with the basics. Suppose I have a list. So what is the brute force approach that may come to your mind, right? What is the brute force approach? So the problem is saying, if there are n nodes, delete the n by second node, right? So what I can do, I can traverse my list and count the number of nodes. So suppose the number of nodes comes out to be ct, this is the count. Then what I do, I divide it by 2 and see what is the index of the node that I need to delete, right? So what I do, I again traverse my list and I delete the node at this particular index. Let me just, yeah, and I delete the node at this particular index, right? This is a brute force approach. So step 1 will be traverse and count the number of nodes, so that will be big O of n. And step 2 will be again traverse the linked list to half the size and delete that node, so again big O of n. So overall it will be big O of n, right? However, so let's see whether we can improve it or not. So just think in this way, that you need to find the middle point, right? You need to find the middle point, right? Now if this is my line, suppose this is my line, right? And I need to find the middle point. So what I am doing, I am calculating the length of this line, I am going to the midpoint, right? So what I can do is that, suppose there are two people, right? Person 1 and person 2, right? So person runs with a speed of x and person 2 runs at a speed of 2x. That means just double the speed of person p1, right? And they are basically sprinting, okay? So this is the length that they need to traverse, right? So let if I talk about the time, right? If I talk about the time, so just see, person 2 is obviously running fast. So person 2, if person 2 reaches the end of the line, covers the this L distance, what will be the time taken? So t2, because it is for person 2, it will be length divided by 2x, right? This will be it. And if I talk about t1, how much time person 1 is taking, so it will be length divided by x, right? So obviously, because the time taken by this person will be just the double of time taken by this person, right? So if I'm going mathematically, I'm going exactly with the mathematical approach. I don't want to follow the jargons, okay? So just see, this is taking this guy is taken 2x time, and this guy is at a speed of 2x, this is at a speed of x, right? Now just see, t2 t2 is the time taken by person 2. So when person 2 reaches the end of the line, at that particular point, where is p1 standing? Where is p1 at till what point has p1 reached? So if I need to calculate the distance that p1 has traversed, so that will be speed of person p1 into the time. So in how much time t2 is person p2 is completing, it is L by 2x. So this is L by 2x. So x cancels, so that is L by 2, right? So this is L by 2. That means if p2 is covering L distance in time t, right? So and p1 is so obviously p1 is taking just the double time. So when p1 reaches L, so in the same time p1 will reach, sorry, when p2 reaches L, p1 will reach L by 2, right? P1 will reach L by 2, right? So this is the basic mathematical solution that I wanted to show. So that means two person traveling at a distance of x and 2x, when the second person, the faster person, reaches the end of the line, then the slower person is just at the middle point, right? And what we need to do, we need to find the middle point in this case for this list, right? And we need to delete it. So what we can do, why not take a couple of pointers, right? Because we don't know the middle point, we don't know this point, but if we know this point, then we can know this point, right? How we know this point? So for the last node, the next pointer is null, right? For the last node, the next pointer is null. So that means I can traverse my array. I can traverse my list. I can keep on traversing my list. And suppose if I had two folks, one is a slow pointer, one is a fast pointer. Slow pointer is moving at a speed of 1. That means it is traversing nodes one by one, right? And fast pointer is traversing two nodes at a time, two nodes, and so on. So as soon as fast pointer reaches the end of the list, I am pretty sure that the slow pointer is at the midpoint. So what I can do, I can just delete this guy and I can attach, this is the previous node, I can attach it to the next node and I'm good to go, right? So we know why the slow pointer and fast pointer approach is useful here, because we want to find the midpoint in a single traversal. So what we'll do, we saw what is the relation between the midpoint and the end point, right? Using some mathematical calculation, some basic stuff. So because we know now, obviously distance is equal to time into speed. This is we know. So based on this formula, we calculated what is the time taken by person 2 and person 1. So in how much, so if I take the same time for person p1, then at which point is person p1 standing when person p2 covers the whole line. So based on that, we know that if I reach the end, then the slow pointer will be at the midpoint. So for that, what we are doing, we are taking a couple of pointers. One is being traversed by one node at each time, and the second basically skips one node, so it covers two nodes at a time, and then we are good to go. So what we'll do, I'll just delete this node and we are good to go, right? So this is the basic explanation. Let's directly jump to the code. I hope the explanation was clear. If still you have any queries, do mention that into the comments. So here you can see on line number 13, I've added the edge case that if head.next equals to null. Now again, whenever you solve any problem, since we are discussing that how to cover the edge cases, becoming a good problem solver. So see the constraints say that you will have at least one node in your list, right? So that means head will never be null. However, if you have a single node, then head.next can be null. So if you have a single node, just return null. Else, take the couple of pointers that I was telling you to take, right? So on line number 16, I have a slow pointer. On line number 17, I have a fast pointer. So you can see that the slow pointer is starting from the first node and fast pointer is starting from the second node, because obviously it skips a couple of things. So one more thing, you can change it to, you can change the fast pointer to head only, and that will also run. If I go here, let me just a second. If you do that, then also it will be it won't have any effect, right? I'll just change that code and I'll just submit it. So because both are starting from the first node, and one will jump one distance, second will jump two distance, and we are good to go. However I've done this. So now I've also taken a previous node. So now what will happen, why I have taken previous node, I'll tell you. So while fast is not equal to null, because or you can start from fast equals to head dot next only, otherwise we will be missing a case that I'll just discuss. So previous equals to slow, because if you see into the diagram on the left side, so you will see that when the slow pointer will reach 7, that means I'll reach the midpoint, then the fast pointer will obviously reach the end point, right? So now I need to delete the node 7, and my slow pointer is on node 7. So obviously I can't delete a node on which I'm standing, right? I need some reference to do that. So 4 needs to point to 1, right? So what I'll do, I've taken a previous pointer, that is right, because before slow moves, previous points to slow. So that means at every step, previous is pointing one node before where the slow pointer is pointing, right? So previous equals to slow, slow equals to slow dot next, and fast equal to fast dot next. Now again, if fast is not equal to null, then again move one step, and then we are good to go. Once we come out of the loop, we know that we have reached the end of the loop, and slow will be pointing to the midpoint, right? So what I'll do previous dot next equals to previous dot next dot next. That means in the diagram, 4 dot next, that is 7. So 4 dot next, that means this pointer will point to 7 connects, that means 1. So 4 will directly point to 1, and then we'll return the head pointer, right? So this is the basic stuff. It's a traditional problem, but I wanted to explain that how we come to the approach that there is a slow pointer and a fast pointer. So if I would have gone with the concept that I explained you how slow and a fast pointer, then probably that was more of a mugging the concepts. But I think we will go this way throughout the playlist, and we'll be solving the problems together and see that what is the best way to discuss these type of problems, right? So this was the first problem, day one. We'll be covering all the problems in 1 month time span, basically discussing 1 or 2 problems daily depending on the bandwidth. So before watching the whole video, once I have explained the problem statement, just pause the video and try to solve it yourself. See that whether the first thing is whether you are able to come to the correct approach or not, and once you are able to come to the correct approach, whether you are able to write the correct code or not. So these are the two things that we'll be working upon, right? So yeah, I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel if you find the content useful. It would be really motivating if you subscribe to the channel. Also, if you want to connect with me on LinkedIn, the link is mentioned into the comments. And yeah, see you tomorrow with a new video in the same playlist. Take care. Bye bye.